Agentic AI. So far in our journey, we have seen AI evolve step by step, right? From data to generative AI, the layer 7. Now the last one is agentic AI. So machine learning learn patterns from the data. Deep learning learn complex representations, if it is image or text. NLP learn language. Generative AI learn to create content, learn the prompt, and based on the existing vector database or internal documents, it helps to create the content. Now we arrive at the next evaluation, agentic AI. I hope if you learn in this way, whatever I explained, I think in a simpler way, right? I think it definitely would have helped. We discussed the practical examples as well, right? MLD and NLP, Gen AI. So now you can think of, right, what is AI is. So you can classify clearly what is data analysis, data analytics, data science, ML, DL, like that, right? Okay. Now, what is this agentic AI? This is where AI moves from simply answering questions to actually performing tasks. Okay, so think about ChatGPT today. If you ask a question, right? If you ask a question, it gives an answer, right? So the conversation ends. But imagine instead you tell AI, hey, can you research about a particular market, let's say smartphone market, right, of India or Asia? Okay. So smartphone market of, then prepare a report, right? And create a presentation and email that presentation to, let's say, my manager, right? And schedule a review meeting with him. Suppose if you prompt this one and imagine if anything, a system is executing each and every task as you described in your prompt and scheduling the review meeting, what do? You directly go and sit in the review meeting. But of course, definitely human intelligence is required to refine what actually the agents do, but we'll discuss, right? But yeah, to simplify our tasks, right? So the AI completes the entire workflow. That is called as agentic AI. Now you know the difference between generative AI and agentic AI. Generative AI creates the content, could be text or image. Agentic AI execute the tasks to reach some goals, whatever you describe, right? The goal is not or no longer generating the text. The goal is achieving some outcome. So you have to understand this difference. So you are achieving some outcome. Earlier, generating, so ML is basically, so build the relation and predict. DL also the same, but more complex representations for, right? NLP, text understanding and classify. Generative AI create some content, wherein agentic AI understand through the language and execute the tasks to reach the final outcome. That is agentic AI. Okay, so from chatbot to agent, right? So let's understand the different using a simple example, right? Suppose if I ask ChatGPT, what are the best hotels in Hyderabad, right? So it gives a list. What are the top hotels in Hyderabad? So that's a chart, right? Now suppose I tell AI that find a hotel near Mindspace. Mindspace is a location or a locality near high-tech city in Hyderabad, okay, in a city in India. So find the hotel and compare the ratings and book a table for so and so. Or if it is a restaurant or it's a hotel, if it is book, if it is, let's say 5,000 rupees, under 5,000 rupees, book a room. Suppose if you want to book a room, or if it is a restaurant, if you want to book a table, whatever it is, and add it to my calendar and send a confirmation to my email. So now AI has to work to do first search the hotels, right? And compare options So GPT will search the hotels, compare options, and help you to pick the best one. That's it. It will display as a content, but you don't actually book the hotel. You don't send an email to you. You don't, update the calendar. We're in agentic. So this is actually no longer answering. This is action. The agent is acting on behalf of you to reach some outcome. Okay. So this is the leap from ChatGPT to agent. So a chatbot is like asking a travel consultant for advice, where an agent is like hiring a travel assistant who actually booked the trip for you. Simple example, right? We hope you understand. So please make sure you know, use appropriately when you speak during interviews or with your business conversations. That's a agentic versus generative. This is a simple example I have given. You can go through this one. Now, so what makes something an agent, right? An agent works in a continuous loop. So this is the loop, right? Think of a GPS navigation, this navigation app, right? It doesn't just give directions once. It constantly checks where you are and adjusts, correct? The moment you open Google Maps, suppose if you are moving, immediately it will also adjust the direction, right? If you are in the wrong direction, immediately it will adjust the right path. Similarly, agent also work, right? So the first step is the reason. What is the problem? Okay. So what I'm trying to achieve, right? What information do I already have? The data, basically, right? So what information I already have. So I'm repeating again, this is very, very important, right? What is the problem? Okay. What is the problem? The first one is what is the problem? And then what I'm trying to achieve. You're achieving something. The agent should achieve something, an outcome. For that, what information do I already have? Okay. So once you have these three things, once you have clear on this one, problem, what I have to achieve, what information I already have. This is the first part, reason, right? Then plan. What steps are needed? What steps are needed to execute that to achieve my goal, right? Which tools? Suppose if you want to build a house, right? So you have to plan everything, how much raw material, how much money is required, everything. Then you start executing what tools required. Similarly, in any case, you need to have the steps too, which are needed, then the tools, then order of the steps. So you have to start the foundation, layer one, layer two, and so on, the way how we discussed last staircase thing, right? So which order should I? So what is the order in our example? Search all the hotels near Mindspace, then identify the ratings, pick up the best rated hotel, then search the availability, then book if it is less than 5,000 rupees, then send a confirmation email to the user, right? So this is actually the planning phase. Now, once you have the steps to execute, you have the order, you know the tools, right? So what tools are required? Some API calls to search Google and some APIs to structure the Google search and sort the ratings, etc., etc. Now, action. Okay, execute the action, right? So the same what I just described. Call APIs, all right, and query the database. If it is internal something you have, then sending emails. So whatever tools are required, so you execute the actions, then you run the code. You write all the code with all the steps, what tools you want to use, everything. Then action is complete. Now, what is the next one? So you have a reason, problem, what do you want to achieve, what information or data you have, and you have the plan, like what steps I have to execute and what tools required and what sort of order I have to follow. Then the action. You start executing the items that you mentioned in the second phase. You act on it, run the code. Then the last one is what happened, right? What happened? Did the action succeed, right? Or did it fail? Do I need another step? Another step. This is the simple workflow of an agent. It's called agent loop, a cycle the agent runs until it met the goal, or I mean, its goal. It determines the goal is, if it is unachievable, again it repeat. Right? Understand? So this is how actually agent works. A simple example, right? So let's say if I put like okay, reduce in our Shopspeare example, stockouts. Stock out means if user is searching for a product, it says no available. The stock is not available. So I'm creating an agent which should reduce my stock outs to let's say 10% or 15%. So what do you have to do? So you have to analyze the inventory. This is an internal data, right? So analyze inventory, identify risky product categories or products, okay, and maybe put a machine learning algorithm to predict shortages, which product may have shortage in next 1 week or 1 day. Then send an email to all the suppliers, right? Then create a purchase order. So everything is digital, right, these days. So you can call through API, make a purchase order, then monitor results. So please spend a minute on this example. Now you understand agentic AI. It's a very simple. So the same example, maybe I'll use my whiteboard. Okay, just a second. Or I'll put a blank slide here. This example is, so reduce stockouts by 15%. So how come we usually, reduce? Think logically first. Any agentic AI problem, right? So first you have to think the logic. So the logic is simple. I have to explore my inventory data, identify the stocks which are going to end in next 1 day. For example, let's do our daily basis or 1 week, a weekly basis, right? So that is your analyze inventory. You write code to your agent saying that, okay, first is analyze inventory. Means what is happening here, guys? Data analysis, data science is coming up here. So do you think to become an AI expert, you should have data science skills, basic analytics skills? Yes, of course. Then identify risky products. What do you mean by risky products? The products which are going to be stock out by in next 1 week. For example, this is also analytics or data science. So you are identifying the risky products, right? Now, what you have to do is based on the past risky products or stock out information, you build a machine learning algorithm, predict the shortage, maybe a linear regression algorithm or a classification saying that what is the probability that this product may fall under stock out in next 1 week. Right? So you build a proper machine learning. You write code of ML. Your agent will go through this ML code. Right? So do you think ML is required? Right? So now you can imagine, how each of the 8 layers are connected together, to become a AI expert. Now, once this is done, what is required? Contact suppliers. Suppliers of the products where your model is telling that in next 1 week, this may fall as a stock out. Okay, that product may not be available. So you predicted already, early prediction. Then you identify the respective seller and put a purchase order. Purchase order means you are ordering some additional product so that if customer is coming and searching for the product, they don't see stock out, right? So this is purchase order. Then you have to monitor the result. What is the achievement here? This one. So you have your information, this is the loop actually. What actually in the I could say AI agent intelligence. Right? How simple this is. Now you think any rocket science is involved here? No. Logical thinking is involved here. You have to have business acumen, a basic business understanding. Okay, if there is a product which is going to be a stock out in next 1 week. So do a deep dive, data analysis, data analytics, how we discussed in our practical examples of machine learning. We did some EDA and defined some hypotheses, all those things, right? Do identify risky products, then come up with the model. Then model will tell you, okay, product item 1, 1, 1, 23, these are three. May chances that stock out may comes in stock out, may have stock out in next 1 week. Then put a order so that the seller will immediately send it to your warehouse. Immediately your inventory will shoot up, right? So that is agentic AI. You have to have a clear reason. You have to plan what steps you have to execute, what tools you need, what the order or sequence. Then you execute, then check whether you reached your goal or not. So this is agentic AI, right? I hope you are clear with the simple example. I'll definitely show you through a practical exercise. We will be doing a couple of agents. Okay. So now the next one is anatomy of an agent. This is similar to how we discussed about our neural network or ML and etc. Here also we have some anatomy, right? So an AI agent has four major components. Okay. First one is the model, the brain, the tools or maybe hands, it's also called tools or hands, then memory, it's nodes, then plan. So brain is basically the reasoning engine. So it reasons. I mean, it understands the reason from your prompt and then it plans, it generate action. Okay, it thinks, it plans, and it make decisions. Okay, that is the brain. Right? So just like for what we have our brain, right? Without brain, nothing happens. We can't think, we can't execute, we can't plan something. So that is the first, layer of an agent or component of an agent, right? So that is the brain. The second one is tools, or also called as hands. So this is like, this is where agents become more powerful. Why? Without tools, an LLM can only generate text. With tools, it interact with the world. Because again, guys, as I mentioned earlier also, if you didn't understand NLP, you will not be a good AI agent expert, agentic AI expert. I'm telling you, you should have clear understanding of NLP and Gen AI. So practice well on those two exercises we did, right? So the LLM cannot generate or cannot interact with the world. It only generate the text or whatever it is, right? Whatever tools you have, if you connect these tools to your LLMs, interact with the world. For example, search in Google, right? Query a database, extract something, send email through an API call. There is a way you can actually send emails automatically. You can automate the process. Then create tickets, customer tickets, etc. Execute code, update your CRM dashboard, everything, right? So just to give a layman like example or saying like brain without hands can't do much. Similarly, AI without tool, your agent without tool is limited, right? So that's about the second component, tools. Then we'll go to memory. So memory allows the agents to remember. So remember what? Previous conversations, customer preferences, the best actions or past actions, maybe like, business rules, everything. Whatever happened, past, right? It actually put in memory. So this is also called as node. Without memory, every interaction starts from zero. With memory, AI becomes smarter over time, right? So this is important, memory. Then the last component is planning, strategy, right? So planning is a kind of ability to break a large goal into smaller tasks or subtasks. I want to reduce my stock outs by 15%. Directly in one line or one model, you can't reduce it to 85% or 15%. Sorry. All right. You have certain subtasks. First, identify the stock out possible items and predict it. So run your model, then identify the top 10, then identify the respective sellers, send an email, etc., etc. Right? So this is actually plan. The goal is to launch something, to launch orders, purchase orders, so that our stock outs is reduced. Or maybe if you want to launch a campaign, marketing campaign, right? So I'll give another example. Let's say if you want to launch a marketing campaign for your consumers. So what are the subtasks here? Identify the competitors and check what sort of campaigns from competitors are right now on, right? Then create the content, means the flyers or marketing, what you call as the creatives, I'm sorry, add creatives. That's the content basically. Generate the creatives, then schedule the campaigns based on the audience or customers which are having high propensity that they accept the campaign. Again, you can bring your machine learning classification here, right? This will tell who are all the consumers that you can target, and you can create the content and pick up the people who are having high probability to accept the campaign, then track the performance. So that is actually planning is what actually separate assistants from the agents, so you can understand the difference between assistants and the agents, right? So that's about the key components of an agent. Now, tool use and function calling. So this slide explains one of the biggest breakthroughs in modern AI, right? So how does your chat GPT suddenly send emails? How does Claude search databases? How does Gemini connect to Google Workspace? It's called functional calling. So you call the existing function and do something. So that is actually tool use and functional calling. Technically, your ChatGPT is not executing sending an email, but you are leveraging the steps that is there in the GPT output to run your next step, right? So suppose if I ask a simple example, right? So let me give a simple example. It's my cursor here. So let me put this. What is the temperature, or how is the weather in Hyderabad right now? Right? The model doesn't know. Instead, it say that, okay, it will call a weather API, and maybe it will search in the Google and then say that, okay, today now is 30 degrees Celsius. Right? So the model uses this result, then respond. So the process is called tool use. So it is using GPT as a tool. It is calling the function. It is giving output, the agent. Right? So if I give Shopspeare, our example, right? If I put like, will a customer, right? Let's say there is a customer A, or maybe let me do stock also we discussed, right? It's product A. So will this product A go out of stock, right? Next week. Okay. So if I put this prompt, will product A go out of stock next week? What agent actually do as a subtask? Check the inventory, check sales trend, and run the prediction model. So then it generates saying that how, there is no possibility or whatever it is, right? So this is how AI moves beyond text generation. So see, for example, get inventory level SKU, right? And these are all agents that you can actually build, right? This is second one, predict stock out, create purchase order, adjust price, right? Update the catalog within guardrails, escalate to human. If it is not done by an agent, then human have to look if it is in something critical, right? So you can create these sort of agents to execute different tasks described here and build an agent. We'll see. I'm not discussing in depth because we have a hands-on practice session, so you will understand more. But theoretically, I hope you are clear now what is agent, what is agentic AI, right? Then memory, short term and long term. So imagine you're meeting someone for the first time every day, right? So suppose, let's say if I'm meeting a person first time every day. So what you would have introduced yourself saying, I'm Suresh, and so on, so, right? Again, if you are meeting the same person tomorrow, do you think you need to introduce yourself again and again? No, right? So the same way, the AI, suppose if there is no memory, so you have to introduce every day without memory. So there is important component memory. We'll discuss what is short term and long term. But yeah, in context, long term and external, right? So for example, current conversation, if I ask, okay, my name is Suresh, 5 minutes later, if I say, what's my name? The model remembers, if I ask, right? But after the session ends, memory disappears. If you close and tomorrow, if you open again, then if you ask, what is my name? It may not, right? That is actually called as short-term memory. Okay. So in context or short-term, only for that particular situation. Then external memory. The second one is external memory. So external memory means like taking notes. So whatever key decisions, key facts, summaries, everything. Okay. Maybe like a project management agent if you're building, right? So that agent stores meeting notes and retrieves them next week also. This is called as external memory. The long-term memory, long-term knowledge base, like experience. If I give an example, right? Let's say a sales agent remembers everything. So what is my customer preferences? What is the purchase history? Previous complaints, if any, from this customer. The more it learns, the better it serves. So this is how agent become digital co-workers. Okay. So memory is very important and is a difference between one shot assistant and a genuine co-worker that understands your context, preferences, and your history. So now you're clear, right? The memory is important for an agent to execute things. Instead, keep on asking the same and same again to save memory and cost and time again ultimately. Right? So that's a memory short term, long term. Now, this is important topic. Okay. Single agent versus multi-agent. So what is single agent? What is multi-agent? One of the hottest topics in today's multi-agent AI, right? Surprisingly, many problems don't need it actually, right? A single agent is one smart agent, right? So does everything. Travel booking agent, room booking, find the flight, find the hotel, book the ticket. That's it. Simple and fast, cheap also, and easy to manage. We're in multi-agent, right? So multiple specialized agents collaborate each other to reach that particular goal. Think of like a company, right? Example, let's say there is a research agent. So this agent only, I'm sorry, not he, it's a system agent. Research agent, research about the products and services, etc. of competitors and everything. Writer, the second agent. This guy gets input from here and then he summarizes whatever. Then the second one, third one is reviewer. This guy will review whatever these guy have actually researched and created as a writing paper, etc. Then after that, QA. Then after that, final report. It's a multi-agent model. So each agent has a specific task to reach to achieve the goal, right? So just like our humans, right? In industry, you do see people who have experience in marketing, human resource, operations, risk, etc. Right? So similarly, if you want to build these multi-agent, you can actually do the same thing. Suppose in my organization, the Mindrise AI, if I am building a career guidance agent, so we will be launching soon, Titi AI, right? So it collects one agent, it collects students' profile, right? The other one, it analyzes the strength. What is the strength and opportunity? Then the third one generates the roadmap. Then finally, the fourth agent review recommendations, right? Together, they produce a better result than one agent doing everything. There are chances that sometimes hallucination may come, or some goals might not have reached because of the information unavailability or some reasons. So based on the need, based on the volume of tasks, you can decide and define your agent as a single or multi-agent system, right? So don't use 5 agents when one agent can do the job. This is one of the biggest mistake people make today, right? So that's about single capable agent versus multi-agent. So, so far, we discussed how agent works with examples, basic examples, and all. Now let's see framework, right? So now we understand what an AI agent is. The next question, I mean, so far we understand. The next question becomes, how do we actually build one agent, right? So think of building an agent like building a website. If you want to build a website, right, web application. So you wouldn't be building everything from scratch, right? So HTML script and all. There are frameworks. Example, React, Angular, right? Node.js, Next.js, Django, Spring Boot, so many frameworks available. Similarly, Agentic AI has its own frameworks. So these frameworks provide the building blocks needed to create, coordinate, and manage the agent to orchestrate all the tasks. Okay. So we'll discuss each and every important framework right now, which is available in the market, right? Before that, simple again, I'm repeating, just imagine if you are building a house, right? So you could make every brick yourself, but you will be not making brick with yourself and building the house, right? You purchase the bricks, right? Ready-made components, and then you start. Similarly, you have to, you no need to put in a heavy programming in Python or any other to build your agent. You just bring your existing framework. Each framework has a certain task, so you just use them. All right. So let's start with the first one. This is the first one, LangGraph. So what it is, LangGraph? LangGraph is probably the most enterprise-ready framework today. Okay, instead of letting agents run randomly, this LangGraph uh, kind of defines the states, the workflows, right? Decision points where actually it require human approval, right? So these sort of things it helps in. It defines. Similarly, it also helps in error handling. Right. So this is the framework. Really, most of the agents right now in the industry, they are using this LangGraph. Right. Example, let's say if there is a approval agent, maybe a claims example or any example you do, right? So you take what you do, you collect all the relevant documents and you verify the KYC and you check whether it is a fraudulent or not, right? Then do a risk scoring. Then simply approve if it is a loan or credit card or anything, or similarly claims also, right? So explicitly you have some state you to define, and you define this LangGraph defines the workflows. So each and every workflow will flow through. Then finally the decision, the action, the achieve to achieve the goal, whether it's accept or reject. So that is okay. Simple explanation is think of LangGraph as a flow chart with intelligence. Step one, step two, step three, and so on, step n to reach the final goal. That's it. Okay, that's a LangGraph. I'll show you in code, Python code. I mean, when we write, how we use this LangGraph when we do hands-on exercise. Right now, the second one is CrewAI. So this is CrewAI focus on teams of agents. Like suppose if in the previous example we discussed, right, research agent, right, writer agent, then QA agent, reviewer agent, sorry, here reviewer agent, QA agent. So to work together as a crew, I discussed this earlier also. This is the best example. If I give another example like Mindrise AI, suppose if I'm in my firm Mindrise AI, if I want, if you want to generate a data science course, right? So sorry, if I want to generate a data science course, what I do, I'll collect latest trends, what is a topic and all, right? Then I'll create a writer agent, create a lesson content, etc. Then a reviewer content, check the accuracy, then check the formatting, QA, and then the course. So QA is best for those scenarios. Okay, so QA is like building a company of specialists. So research, writer, reviewer, QA, like this. Right. The next one is AutoGen. AutoGen is also called as AG2. Okay, originally this is from Microsoft, designed for conversational multi-agent. So basically, this is agent to agent conversation. Okay, I'm sorry, agent to agent conversations. So example, right? Suppose if I say one research agent, what is the latest, what are the AI trends, latest AI trends, right? Then the writer agent will come up with and give some draft. The reviewer will come and say that, hey, I found 3 issues. Then writer agent will go back and correct them, right? So, sorry, correct them. So agents talk to each other until the answer improves. So that is actually autogen. Okay, it is like, watching your co-workers and discuss a project, right? You do kind of brainstorming session. One come up with an idea, one come up with an idea, then you co-workers, you collate and you finally come up with the best one to deploy, right? So similarly, here also autogen helps as a conversational multi-agent. All right. So then OpenAI agents SDK. So this is basically kind of GPT based agents with some tool use. Like suppose if there is a functional calling is required in your agent, or any if a tool if you want to use, right? And memory related, it also provides the memory. It also helps in workflow management. So the same actually I have responsive AI integrated with OpenAI stack. Basically, OpenAI is your ChatGPT, right? So if you are using OpenAI API call for your agentic tasks, you can use SDK, right? So suppose if I say a customer service support agent, if you call and ask, hey, where is my order? What that agent will do, call orders database, it will go and check, then receive the status, then it will respond, right? So through OpenAI. ChatGPT API, right? So that is actually OpenAI. Similarly, this Anthropic Claude best for any use. Like suppose if you have a open browser, click buttons, fill forms, download reports, these sort of computer-based stuff, right? So giving your access to your computer screen. Suppose my personal machine, if I build an agent to access my personal machine and execute things for some goals, right? Just like a human, this is the best one, Anthropic AI. Okay. Claude computer is like giving an AI a mouse and keyboard. That's it. Instead of me as a human operating mouse and keyboard, the Claude computer will operate and execute tasks as per your definition or rules. Similarly, Google. If your product stack is on Gemini, Google Workspace or Google ecosystem like Drive, Documents, Google Vertex AI, right? Google Drive, Google Gmail. So everything is on Google, right? Suppose your product's not, then better to use Google ADK for your orchestration, for your framework, agent framework. Okay, right? So that is about Google ADK. Simple example is suppose if I want my agent to read my Google Calendar and identify the meetings, summarize the meetings, and save the notes in Drive, then send an email, Gmail. If everything is in Google, right? So that is about Google. So don't pick a framework because someone says it's hard. Pick based on your use case. So for content workflows, use CrewAI. For entire workflows, the best is LangGraph. For OpenAI ecosystem, if you're already using OpenAI API calls, then use OpenAI SDK. For Google ecosystem, use Google ADK. So these are the popular agent framework, in 2026. Please explore, keep on exploring. After a few months, you may see another framework. If it is more reliable, you can or relatable, you can change it to the respective framework. All right. So, okay. Now let's come back to our example. Example. ShopSpeare's autonomous operations agent. So, what is operations in our example ShopSpeare basically? Right? So you get your stock from your sellers, and then whenever there is an order, you pick it up and deliver it, right? So just imagine you are an operations head, right? So there are like 500K products and 200 warehouses, thousands of orders daily. So imagine this is your landscape, right? So can human monitor everything? No, right? So this is where our agents really help. So become valuable. What is the first step they do? They actually continuously monitor the inventory levels, sales velocity, the returns, the supplier delays, everything they monitor and create a report, right? This is what your layer 1 and 2, your data and analytics, right? The second, what is the second one? Predictor, right? So agent calls an ML model. You already have an ML model. This is what your layer 4. So here layer 1, 2, 3, the second predict, layer 4. So 90% of chance that product A, may fall in stock out in 14 days. Now, AI isn't just seeing the present, it is actually forecasting for the future, right? So that is your prediction layer. Now, then the next one is acting. Agent can now generate a purchase order based on the output from your previous step ML output. This product, there is a probability of 90% chance that this may fall under stock out. So it will make a purchase order. So suppose, notify the supplier, then increase the price slightly because it's a shortage, right? So people ready will put higher price also. So definitely, right? That is how business, gains value. Then, or if you want to put more price to the supplier, you can put because it's urgent for you. You should not lose your customer or consumer, right? So that's actually acting. Okay. In meanwhile, while you get the things from the supplier, you can promote alternate products. Every product is an alternate product, right? So just right. So a dashboard actually shows a problem. Agent solves the problem. Then it actually identify the prediction thing, then act it. So see the difference between dashboard versus agentic. So if you put an agent on the dashboard, it will continuously follow and identify the output from ML and get the best actions. The last one is escalate. If any decision, if order is greater than, let's say 50 lakh INR or 50K dollars, something like that, right? Then you have to escalate it. So agent should not decide alone. So human approval is definitely required. So, right. So the good agent know when not to act. So this is actually enterprise grade AI. Actually, Amazon has built these type of agents. It's in live recently. They started, and every operational module has an agent. So they reduced stock out, they reduced returns, they reduced I would say deactivation or becoming inactive of consumer base. It's really working well. But again, based on the need, please make sure as and when a human approval is required, and you have to put a human loop and make sure you are helping in gaining the value of the business. Okay. So similarly, another use case for same are what you call Shopspeare, right? So a multi-agent customer resolution queue, right? So this is a perfect example of why multiple agents can outperform one agent, one giant agent, right? So customer requests for, let's say, refund, right, at midnight. Imagine. So no support staff available. Traditional process is what? So they have to go through things and the customer wait until morning, agent processes, issues resolved automatically. Right? I'm sorry. Human customer service agent, they process tomorrow morning and issues resolved automatically. This is what is the issue here? Time. Customer may get, some distraction, some negative sentiment. Right? So instead, you just create a track agent, right? Actually reads the request, classifies whether it is, refund request or, whether it's an urgency, etc. and all. Check the customer history, whether the customer is earlier did any fraudulent transaction, right? So then let's say example, customer says, hey, my product arrived damaged. Client agent categorize category, refund, priority, high. Then it goes to the next one, policy agent. Check the refund policies using your rack system, whatever you have, right? The policy says, okay, refund allowed after 30 days or 15 days. Customer purchased 10 days ago. Okay. So then it is eligible or not eligible. Then action agent. So actually process your refund. So call the payment system and update the ERP, generate some confirmation, right? So very important here is without tools, AI can only say you're eligible, but with tool, some tool, okay, we discussed different tools, right? Actually issue the refund. So you are building a connection between your ERP system and your output, whatever you got from your agent here, right? So the last one is QA. So it actually verifies whatever the earlier agents have done, the customer ID, the amount, the payment method, everything, right? So this is how actually it goes. If it is, you can put a rule saying that, okay, the amount is greater than so and so, then human approval is required. So definitely it will, this particular part go to a human will approve, then it will complete the payment, right? So in this simple use case, what you have noticed, what you have to notice and understand is the traditional way is 12 to 24 hours or 48 hours. Where an agentic is 1 to 2 minutes. The customer happier, support cost lower, employees focus on complex cases. Now, this is how you can leverage AI to optimize your cost and time. Okay, so that's about multi-agent customer example, solution queue example, right? You can think like this any number of things, but again, please, validate if it agent is really required. Where human is spending more and more hours, definitely bring agents through ML and DL or DL, then obviously it helps to reduce the time and cost. Okay, before I wind up this and before we start our hands-on exercise on agentic AI, again to the way how we discussed about guardrails in Gen AI, responsibility, guardrails, and risks. Right? This is probably the most important slide in agentic AI. Okay, why this is important? Why this is important means you are actually building an agent. You are building a relationship or connection between one agent and another agent, one database to another API call like this. So you have to make sure that before any agent can take action, it should not create any risk. You have to put guardrails. Okay, imagine a simple example. Sorry, yeah. Simple example. Imagine you have an inventory agent, right? So it mistakenly order, let's say 10K laptops instead of 1K laptop. Imagine what you have created a 50 crore problem, right? So that's why it's very important for you to put risk guardrail properly defined for your agent and make sure you're building a responsible agent. If there is a need for such cases, then definitely human approval is required. Right? The smarter the agent becomes, the bigger the damage if something goes wrong. This is very, very important. That's the reason in the beginning of the session, I have mentioned clearly, Gartner reported like 48% of agentic AI projects are going to be scrapped by end of this year. The reason is these kind of examples. Okay, so human in loop, basically simple rule, right? High risk decisions require humans, right? So agent can draft email, but agent cannot send legal notice without approval to a supplier or a vendor, right? Similarly, agent can suggest one price change, say that hey, there is a demand increase price $10 to $12, but they cannot change prices by more than 50%, right? So without any approval, human approval. So that is about human in the loop. You have to bring human in the loop for critical scenarios. Just know how we discussed, right? What we discussed. Then permission scoping. So there is, you have to give minimum permissions. So for example, there is an inventory agent. So you have to give permission to inventory data, supply system. But you should not allow inventory agent to access payroll system, HR records, finance database, right? That is input. That is guardrail. So your agent should only access whatever is required for that agent's tasks, the respective action goal, not someone else, right? Just like if you're a manager in a company, you should not have access to payroll system of others, right? Similarly, you have to define these guardrails and be uh, this one, a responsible agent. Observability. What does it mean basically, right? So track everything, log everything, and monitor everything. So you have to do that. Otherwise, if something goes wrong, and then the example that we just discussed, 50 crore problem, right? So if agent approved a refund, need to know why this is approved. Okay, which policy is allowing agent to approve, and which tool allowed agent to approve, which data source, right? So without logs, there is no debugging, there is no auditing, there is no trust. Make sure you observe everything and put certain rules if agent is in limits or not. Okay, the last one is cost and reliability limits. Imagine a poorly designed agent, kind of, searching Google, getting a API call, searches again, calling API again. I mean, again, is leveraging an API call, repeats 500 times. What does it mean? Your bill explodes, right? Every call is a cost. Every token exchange between your API, your ChatGPT to your system is a cost. So it's important to make sure that you put certain limits. If it is more than 10 times, block it. Put a human intervention or check why it is actually doing these many times. Right? So set the guardrails, set the maximum iteration, set the budget limit, set the timeout, set the API calls. So this is about risks, guardrails, and responsibility. So very important while you build agents, right? Without this, you may end up, in losing a lot of money for your organizations, right? That's about agentic AI theory, right? Before we start our hands-on exercise, right? So I want to leave you with one final thought, okay, about agentic AI. The challenge is no longer making AI intelligent. We have already achieved that, right? The challenge is making AI reliable. So an agent can think but cannot be trusted, okay? Cannot be trusted until unless you as a human validate it. So an agent can act, but has no guardrails. If there is no guardrail, there are no guardrails, then it is not a liable. Okay. So the future belongs not to the companies build the smartest agents. Instead, build most trustworthy agents. Okay. Please underline this word. Not to build smartest agents where do things smarter, but build agents, the most trustworthy agents, right? So now let's move to the worked out example of agentic AI. Orchestration. What is orchestration? So we just discussed about multiple agents. Imagine you have multiple agents, right? So how do they work together? If you recall this orchestration that we discussed during our data engineering, right? So data engineering, how to define the rules and validation pipeline and etc. etc. An orchestrator, a couple of tools, Apache, right? So they actually work as an orchestrator to make sure that the sequence of pipelines get through your data, get through the pipelines and create a clean data for analytical consumption, right? So similarly, here also in agentic AI, there is a orchestration just to make sure that how all the multi-agents work together, right? So three broad categories here, right? So one is a crew AI style. So think of a project manager, right? So manager assigns some tasks. Researcher, they will go on to the research. And the writer, they write the content, editor checks for any issues in the language, etc. Right? And the QA and everything, right? So very intuitive, easy to build and excellent work, content generation workflows. So this is CrewAI style, or this is basically this example. If you have similar examples, you can use this QA style orchestration, right? So maybe I can give one more example, right? So let's say in pharma, right? Pharma, there is this important concept called market access. So what is market access is once, they before they launch the drug, or what sort of patients able to access the drug. That is market access, and what sort of people these guys can reach out, right? So what they can do, they can actually research about the patients and the disease, right? Data analyst analyze the data, a writer, right? And then QA, then the final report. So great for content workflows. Here there is no ML based or DL based execution exists here. Something which is bit generic like research, create a content and validate it and publish it. So this is QAA, QAA. What is the meaning of Crew? Basically, if you look at a project manager, he works as a member, right? So that is QAA style. So I'll give example when we discuss practical exercise, right? So don't worry about it. The second one is the explicit graph, LangGraph style. So think of a flow chart, right? How flow chart usually we design. A flow chart is this is my step one, then after that it goes here, then this is the process, then this is the process, this is the process, and so on. Right? Every step is predefined, controlled, very controlled and very reliable. So perfect for enterprise level systems. This is LangGraph style, right? Suppose in insurance, right? So think of insurance claim process. You are building an agent to process the claims. What is the steps? What are the steps here? First, receive the claim from the patient or healthcare authority, healthcare organization. Then you have to validate the documents, right? Then check for fraud if this is fraudulent claim or not. Then go and approve or reject, right? So notify customer how much it is approved. Simple. You're automating the entire earlier, ML output manually. People used to go through and then come up with a conclusion. But here now, if you build an agent, it will take care of everything. So these sort of things, LangGraph style is the orchestration is very important because there is a lot of tasks like so. I could say here, yeah, steps, edges, transitions, everything you need to explicitly, right? So this is explicit graph. I'll give examples for same or shop sphere ecom, right? So you will understand more. Then the MCP, Model Context Protocol. Basically, this is the newest concept. Think of MCP as a C port for AI, right? USB-C port, right? Different charges for different devices. If you have C port cable, right, you can put any brand, right? You can bring any brand phone or laptop, you can actually charge it. Just similar to that. Model Context Protocol Orchestrator is one of the best way to connect any agent to any tool or any data source to orchestrate your flow. Okay. So before MCP, I think custom integrations were doing like for every tool, but after MCP, one standard way for agents to connect with tools, right? So these are the three different patterns. I'll show you all three when we practice example, right?